Hello and good day, Algebra. We are continuing our study of systems of equations. As promised, this objective also starts with I can solve a systems of equations, but now our method is changing. We are using something called substitution. Because, let's face it, not only is every equation already written in slope-intercept form for us, and so graphing it might not be that easy, but we don't always have coordinate planes with us, right? I assume that none of you are like me, where I always have a coordinate plane tucked away in my pocket, or wear shirts that are a natural coordinate plane so I can graph anytime, anywhere, okay? So another method that we have at our disposal, another tool, is a method called substitution. And substitution basically means that we are going to be replacing a variable with an expression. Okay? We'll be replacing a variable with an expression. I hope so. Whoever said easy, I hope so. That is always the goal. Okay? And what I mean by that is, take a look at the equations that we have here, this first set. We have y equals 3x plus 2 and x plus 2y equals 11. Now, again, being a system, we're not interested in just, what's the value for x and y that works in only one of them. We want to know the value for x and y that works in both of them. Okay? I'm going to rewrite these equations using different colors so that we can kind of identify what's going on here. We have y equals 3x plus 2, and we have x plus 2y equals 11. I define substitution as replacing a variable with an expression. We actually have a value for y here. We know what y equals. It's not a number, but what expression does y equal? Caleb. Oh, I thought that was a hand raise. Sorry. Do you have an answer? Thomas? Right. The top equation says y equals 3x plus 2. So in the second equation, watch what happens if I replace my variable of y with 3x plus 2. How did I just greatly improve my ability to solve this equation, solve this system? Violet. I now have one equation with one variable to solve. Okay? If I know that y equals 3x plus 2, the substitution method tells me that I can replace the y variable in my other equation with that expression. Because y and 3x plus 2 are the same thing. That's what the equal sign means, right? So, and I'll write this up here. I know I'm kind of at the bottom of the page here. But the equation that I now have to solve, x plus 2 equals, x plus 2 times 3x plus 2 equals 11. How am I going to solve that? What's my first step, Caleb? The distributive property, right? All the way back to PO10, where we talked about when we have multi-step equations here. I've got parentheses, so I'm going to have to distribute my 2 into the parentheses, and that gives me x plus 6x plus 4 equals 11. Because 2 times 3x is 6x, and 2 times 2 is 4. Now what? What do I do next? Gino. Combine the like terms. I have 1x here, 6x is there. Total that gives me 7x plus 4 equals 11. And I now have a two-step equation. 7x plus 4 is 11. What is my value for x? What does x equal here? James. X equals 1. And now that I know what x is, how do I get y? Sepa. Right, I go all the way back to this first equation where it says y equals 3x plus 2, and now that I know what x is, I can substitute or replace that x variable with 1. So y equals 3 times 1 plus 2, and my y value is 5. Okay? And if I plug these two things in, plug these values in for x and y in the top equation, does 5 equal 3 times 1 plus 2? Yes, it does. In my bottom equation, does 1 plus 2 times 5 equal 11? Yes, it does. So I know that I'm correct. Okay. If I were to graph these on the coordinate plane, at what ordered pair would the lines intersect? At 1, 5. Right? But it all goes back to this particular concept here. The hardest part that students kind of find is where do I start? And it's starting with recognizing that we have a value for y. It's an expression, but it's still a value. So in the other equation, we substitute that value for y in, giving us one equation with one variable to solve for. Okay? Now, it's the first time you've ever seen anything like this, so if you're, have some questions, that's totally fine. Would you like to ask any of them now? Michael?
What just happened?
The substitution method just happened. Luckily, we have enough time to go over more than just one example. So as we go, if you get lost, stop me there, right? Don't wait till the end, okay? Stop me when you've got the question and we'll go over it, okay? Well, let's start with the second one then. Okay, let's take a look at that. I'll give myself some more space to work here. Look at all that space to work. Oh my goodness. Okay, so our second system here, we have x equals 2y minus 6 and 4x plus 6y equals 4. I'm looking at that top equation because I see that it tells me x equals 2y minus 6. What do I do with that? That piece of information is important. What do I do with it? William?
Plug it into x.
Right, in my other equation, okay? If x equals 2y minus 6, the fact that these equations are a system means they've got that relationship, right? That means in my other equation, I can replace the x variable with 2y minus 6. Right? Everything else in that second equation stayed the same. The only difference is that I replaced my x variable with the expression that it equals, 2y minus 6. Anyone need me to stop? Good?
Keep going a
little bit? Okay, good over here? All right, okay. So now that we're at this step, notice that we only have one equation with one variable to solve for, right? By replacing the x with the expression 2y minus 6, I now only have to solve for y. I've got parentheses, so I need to distribute. 4 times 2y is 8y. 4 times negative 6 is a negative 24. And then I have my plus 6y, and all that equals 4. Now that the parentheses are gone, I look for like terms. I've got 8y's here, positive 6y's there. Total on that left side, I have 14y's. I don't use opposite operations here. I would not subtract 6 from 8 because I'm only working on one side of the equal sign, right? When we're combining like terms on the same side of the equal sign, we don't use opposite operations. Opposite operations are used when you're moving something to the opposite side of the equal sign, which we're not doing here. We're combining. So 14y minus 24 equals 4. Now I want to move that constant negative 24 over to the opposite side. And so to do that, I'm going to be adding 24 to both sides to cancel it out. The opposite of subtracting 24 is adding 24, and that gives us 0 there. So 14y equals 28. I'm multiplying 14 and y together here, so the opposite of that is division. So divide both sides by 14, and y equals 2. Did I lose anybody? Ah, how do we get x? How do we get x? Drew?
Y into the top equation.
Right. Remember that topic equation there, that x equals 2y minus 6? If we now know what y is 2, then we can rewrite this equation right here to read x equals 2 times 2, replace the y with the 2, minus 6, which gives us what? Negative 2. So y equals positive 2, x equals negative 2. Okay? To check this, last time we plugged them into both equations. You could certainly do that. You wouldn't necessarily have to because this negative 2 came from using that top equation. So if it works in the other one, 4x plus 6y equals 4, then you can be pretty confident that you've got the right answer here. So to check this, does 4 times our x value, negative 2, plus 6 times our y value, positive 2, equal 4? Does negative 8 plus 12 equal 4? Yes. So we can be confident we've done it correctly. Okay, there's your second one. How are we doing? Michael? Yeah? Okay. This side of the room over here? Thumbs up? All right. Okay. So now we look at the third one. What's different about the third one than the first two? Seppa? What do you mean? I'm solving for two variables in all of them, but what do you mean? Well, the difference here, kind of going along with what you're saying, in the first two, one of my equations had a variable already by itself. It was y equals something. It was x equals something. Here I've got 3x plus y equals negative 7. I don't have a variable by itself. Big problem or minor problem? Peter?
Big problem?
Minor problem.
No, it's minor.
Okay? How can we fix this? If things aren't the way that we want them, the nice thing about math is we can make them the way we want them. How do we do it? Adam? Right. If I want y by itself, and the reason why I'm going to choose to get y by itself here is because it doesn't have that coefficient, if I try and get x by itself here, it's going to be much more complicated than just getting y by itself. But if I want to do that, 3x plus y equals negative 7, all I need to do is subtract 3x from both sides, and now I've got y by itself, which equals negative 3x minus 7. So back in the day, when we learned how to convert from standard form to slope-intercept form, this is why. Okay? When we learn how to move terms from one side to the other, this is why. We want to get the y variable by itself, and so to do that, we need to move this 3x over to the other side, which means we're going to subtract 3x from both sides. These can't be combined because they're not like terms, so it's written as negative 3x and a negative 7. And now are we in business?
Yes.
Now we're in business because we know what y equals. Y is equal to the expression negative 3x minus 7. So in our other equation, when I go to write this, negative 2x plus 4 instead of y, what am I putting in? Blake.
Y equals negative 3x minus 7.
Except for I don't put the y equals part, right? It's just the negative 3x minus 7. And all that equals 0. Okay? So for the substitution method, you need to have one variable, doesn't matter which one, already by itself. If one's not by itself, then it's only a minor manipulation to get there. And then you can rock and roll. All right? Questions? Okay. See if you can solve it from this point the rest of the way down. Right? I'm going to pause the video here, give you a couple minutes, see what you can do, and then we will come back and discuss. Okay, and we are back. We went through the work for that third one there. We came up with -2 and -1 as our values for x and y. Of course, reminding ourselves, because it will come up again, that if we were to graph these equations, that would be the ordered pair where they would intersect, right? Which is why the graphing method also works. So, questions? Okay. It is a good thing. Okay, let's look at the second page, see what that has in store for us. This key point here, your solution should be written as an ordered pair. Why was it represented? We already talked about that. It's where the lines intersect. I don't think I wrote my answers as ordered pairs, but you should do better than I do. Okay. Taking a look at this page, pick one you would like to do together. Only the first one I was being kind with and gave you yeah. Yes, Michael.
The last one.
The last one. Uh-oh.
What a shock.
Why the last one?
The second one. Fine. The fifth one because Joe's crying.
Well, you know what? Actually, you know what? Hold on. Hey.
I do the second one. It's the hardest.
Shh. Okay. I'm only going to give you the top 3 for homework tonight. So let's actually focus on those. Give me one of these you would like to do without just yelling. Seppa, thank you for the hand raise. Or are you stretching? Okay. Joey. The third one? Okay. X plus 4y equals 6, and 6x plus 2y equals -8. Looking at these equations, remember I said the students tell me, I don't know where to start. Okay. Where do you start here? What are you looking for? What are you trying to identify, William?
A variable.
A variable that what? Doesn't have a coefficient written, right? You're looking for the variable with a coefficient of 1. Okay? And in that system, in that third set, where's that variable with the coefficient of 1? Feel free to raise your hand now and answer the question. In that third system, where's the variable with a coefficient of 1? X in the first equation, right? Both y's have coefficients. One's got a 4, one has a 2. The x in the second equation has a 6. We care about this one, okay? Because that's the variable that we want to isolate. That's the variable we want to get by itself. We have a minor problem in that it's not already by itself, but with a little manipulation, we can get it there. By moving those 4 y's over to the other side of the equation, we will get x by itself. And since we're moving those 4 y's over to the other side, we're going to need to be subtracting opposite operations 4y from both sides. Okay? That leaves us with x by itself on the left and -4y plus 6 on the right. We can't combine 6 and -4y because one has a y and one doesn't. But we've isolated that x variable So now we can use that substitution method and replace that x in the second equation. Going to our second equation, instead of x, we'll be writing negative 4y plus 6 plus 2y equals negative 8. Okay. Again, why that was helpful too is that now we have one equation with one variable to solve for. And so now just the algebra. What is going to be our next step to solve for y? Joey?
Distribute it into the parentheses.
Exactly. Okay. In goes the 6. 6 times negative 4y is negative 24y. 6 times positive 6 is 36. And then we have our plus 2y equals negative 8. Next step. Sepa. Yes, combine those like terms. And again, because they're on the same side of the equal sign, we're not going to be using opposite operations here. We are not moving them anywhere. We're just combining. Okay? So negative 24 plus 2, negative 22y plus 36 equals negative 8. If you got negative 26y, you subtracted. You went the wrong direction. Okay? And now we've got our two-step equation that we can solve. Okay? Subtract 36 from both sides. Negative 22y equals negative 44. Divide both sides by negative 22. And we get y equals positive 2. Questions on that process? Okay, where do we go from here? We got y, we still got to get x. William?
Plug 2 into the 4x.
Plug 2 into the x plus 4y equals 6, right? We can use this equation. We can also use that one with x already by itself, okay, which might be a little bit easier. So in that equation, x equals negative 4y plus 6, we know what y is. So we've got x equals negative 4 times 2 plus 6, or negative 8 plus 6, x is going to equal negative 2. Okay? Do we feel confident enough that we can tackle the other two with some success?
Yes.
Okay? The first one, y is already by itself for you, so you don't have to do any manipulation. You can just dive right in. The second one, you've got to do a little bit of manipulation first to get that variable by itself. So just those two for tomorrow. Okay. Any final questions, comments, concerns, complaints, comments, or congratulations? All right. With gusto. That's how you math.